Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is number of subarrays of zeros, and it is a easy level problem. So this particular problem is like pretty standard. By standard, I mean that if you're doing programming for a few months from now, you must have already seen this problem in many places. So this is just a repeated problem, and you'll be easily able to solve this. And this is a good beginner-friendly problem. So if you have not solved this, you will find this problem very interesting. So let us quickly start with the problem statement. It says that we have been given an array of length n of zeros and ones, and we just have to find the total number of sub-arrays of zeros. So for the first test case, the answer is 4, and let us discuss the both of the test cases so that it is easier for you to understand. So for the first test case, the array is 0, 0, 1, 0, right? So the first subarray is this one, and the second subarray can be this one, and the third subarray is this one. So we have already found 3 subarrays, right? And one subarray can be this one. So what is a subarray? Subarray is any array which has contiguous elements, right? You cannot take this element and you cannot take this element and count it as a subarray. The elements have to be together and they have to be in a contiguous fashion. So we just have to count the number of subarrays of 0. So we have to count the number of ranges L and R. Let me just write it down in a different way for you. So we have to count the number of ranges L and R such that L is less than or equal to R, and all the elements between L and R are 0. Right? This can be also a question. Right? Number of pairs of L and R. So the same question is like presented in a different couple of ways, and they all mean the same. So in this case, we found 3 plus 1. The total answer is 4. Right? Now let us discuss the second test case. Now it is more of a general case. You will see for n is equals to 4 what happens. So if you have found a subarray of length 4, or you have found an array of length 4 which has all zeros, how will you count the number of subarrays in this complete array? Right, this is our question. So one subarray is the whole array itself, so we have 1. Right, now if we reduce the size of the array by 1, so if you take the size of 3, so one array can be this one and the one other subarray can be this one. So you see there are 4 possibilities. Right, if we reduce the size by 1, if we take size subarrays of size 2, then one subarray is this, second subarray is this, third subarray is this, right? So these are the 3 subarrays that we will have. So the answer is 3 in this case. Now if we reduce the size by further 1 and we only have a subarrays of size 1, this will be one subarray, this will be one subarray, this will be one subarray, and the last one is this. So the total number of subarrays in this particular case is 4. Now if you add all of them, the answer will be 1 plus 4 plus 3 plus 2, that is 10. Right? So this would be the final answer. So for n is equals to 4, if you have observed till now, it's nothing, just summation of I, where I is from 1 to n. Right? This is the answer for any array. If you have an array of all zeros, the number of subarrays from that you can form from that array is this particular thing. Right? And you can easily find it with the formula n into n plus 1 by 2. Right? This is the formula for calculating this particular value. Now, how is this information useful? For example, you have some subarray. For example, in the first test case, you could have divided the problem into 2 parts. So this is the first array that you have of size 1, and this is the second array that you have of size 2. Right? So in this particular case, the answer would be 2 into 3 plus divided by 2, that is 3, which we have calculated from here. Right? The same thing. And in this case, the answer would be 1 because 1 into 2 by 2 is 1. So you see that you just need to count the number of contiguous ones. For example, the number of ones which are together, then you can just apply this particular formula on them, right? So this is very straightforward question. Now let me just directly show you the code for this particular problem. Now it is for you can just initialize your answer and count variable to 0. So both of these have to be long. You just have to take care of this particular thing. That they ask us to return long. So the total answer can be pretty huge. So what I've done is I just initialize both of them to 0, and I've just initialized the follow from 0 to less than n, and whenever array of I is equals to 1, that means the chain of zeros that I had has been breaked, then I'll add count plus 1 into count by 2 into my answer. So the count is the current number of zeros that I have, and I'll reset the number of count, or I'll reset the value of count, right? So what happens after that? If the array of I or the current element is 0, then I just increment the count. right? So whenever I am having a 0, I just increment the count. Whenever I found a 1, that means the chain of zeros is break. I just increment my answer by this particular value. So at the end, I just do the same thing. Why? Because there might be a case whenever I have conditions like this. For example, in this particular case, I never encounter a 1 and the array ends it. So the current length is 4 and I have not included it in my answer. So I just need to include it after the for loop as well. Right. So this is why I have this particular statement here, and at the end, I can just return the answer. So this was it for today's problem of the day, and this was a pretty straightforward problem and like a pretty much used everywhere problem. So I hope you guys were able to understand the solution. If you guys did, then you can consider dropping a like on this video, and don't forget to subscribe to this channel. It's always free of cost, and if you don't find the videos of much value later, then you can always unsubscribe. So till the next video drops, keep coding, stay safe, bye bye.